Let's make a plot of the magnitude of the velocity as contours. Select this icon over here, contours. Let's call that velocity magnitude contours. Click OK. And I'm editing velocity magnitude contours. I want the contours over periodic 1, and as I move over these locations, it highlights what the location is. So I want periodic 1, and the variable I want is the magnitude of the velocity. So that's the magnitude of the velocity, and let me explain how that's calculated. So the magnitude of the velocity in this case is going to be the square root of the axial velocity squared plus the radial velocity squared. And that's how that particular variable is being calculated. And I'll keep the number of contours the default and say apply. And I can move this a little bit to the right if I select the pan button here. And I can zoom in using the right mouse button, and I see there is, I could get smoother contours if I increase the number of contours. So that's, let's say, 51 contours, and there'll be, it puts more contours in. All of these contours are calculated by interpolation. I like to get a view where I see, this reflected down, so it looks like you're looking at a cross section through the pipe. And to do that, you can go into view and say apply reflection mirroring and reflection about ZX plane, which is the plane perpendicular to the screen, and say apply. Unfortunately, this shows me only the reflection below, whereas I want both of these in the same view. And a student found a workaround for this. So let me deselect that and say apply. And then go to default transform. So if I double click on default transform, disable this instancing info from domain, and then that'll enable me to reflect within this default transform. And I believe that applies to all the plots, and make sure that the reflection is about the ZX plane over here, and say apply. So that gives me a view that looks like a cross section through the pipe. And let's compare this view with what we with the expected trends from pre-analysis. So let me bring this and the PowerPoint side by side. Here I have the velocity magnitude contours side by side with the graphic from the pre-analysis. Let me move this over here, and I can zoom out using the middle mouse button. So over here I see that the velocity is around 1, and I can actually go in and probe it. So if I say probe and select this probe icon here, and I want to probe and make sure, so you have to go into other and pick the variable to be probed as the axial velocity. So that's the axial velocity. And you see that, and let me probe over here. So it's around 1, which is what we expect. And if I move along the inlet, it stays at 1. So that's a check on my boundary condition. Over here, it looks like it's 0. So that's another check on my wall boundary condition. So that way I've quickly checked my inlet boundary condition and my wall boundary condition where I'm setting the velocities. And as I move along the pipe, I see that the velocity increases, and in fact it becomes closer to 2. So if I compare this to this view, I see that the velocity is at the center line is accelerating from 1 to about 2. And the boundary layer development, so here, the boundary layer development, let me move this a little bit to the left, it'll let me, over here. The boundary layer development is a little bit more subtle than what is shown over here, but I do see that there is a boundary layer developing and consequently, slowing of the flow here and corresponding speeding up of the flow near the axis. And I can keep probing and so on. I get rid of the probe and I will say zoom to fit and bring this back.